Now, before starting, I would like to ask you some few questions that we have already done in our previous class, right? We have done that your laws of refraction. In that, Snell's law of refraction is there as first law of refraction. What does that first law of refraction states? Rather, you can tell me that Snell's law. What does Snell's law states?
The
Ratio of
sine
Can you please stand up and say?
the ratio of sine angle emergent incident angle of incidence
Angle of incidence, that means sine of angle of incidence
by
by
angle of refraction.
sine of angle of refraction is equal to
Refractive index.
refractive index, Ri. So we denote it by N, right? Yes. So sit down, thank you, sit down. That is what you will see here. Okay, this is that of refraction through glass lamp, and the light goes from rarer medium to denser medium, and you will see there what happens, sine of angle of incidence and sine of angle of refraction, and this angle is the angle of emergence, angle between the emergent ray and the normal at the point of emergence. Now, that was what I said, that expression of Snell's law will be here. Got it? In the case of glass slab, what is the relation between angle of incidence and angle of emergence? Vidika, tell me.
Sir, angle of incidence is equal to angle of
Right, very good. Thank you. So now, angle of incidence is equal to angle of emergence. Right? This is in the case of glass slab. But it will not happen this thing in the case of prism. Prism. Have you heard about prism?
Yes, sir.
Can anyone tell me what is prism and what is a relation, or rather what is a formula for prism? Prism formula or prism? No one. Yes. We haven't started this prism class, right? So we will try to learn about that of prism and its formula. Okay? That will be our topic. That is what? Our topic is what? This is refraction through prism and its prism formula. Okay? So let's start it. So now, this is a prism. Okay? How will you define prism? Prism is a transparent medium. It is a transparent medium bounded by two plane refracting faces. This is one rectangular plane refracting face. The other one is also here as plane refracting face. So when these two plane refracting faces incline to each other, okay, making some angle, then what happens? It constitutes what is known as prism, and it can produce what? The phenomenon of dispersion also. Don't you like to learn to know what is dispersion? Yes, no? So I will tell you that one also. So first, let's see. This is a light ray incident, refracted, and it emerges out. So let me show you again. This is what? Incident ray, refracted, and it emerges out. Got it? So like that. Now, let me show you how this, this refraction through this glass prism takes place. So ABC is a glass prism, I should say outline of that glass prism, and mu is the refractive index of the material of this transparent prism. Got it? ABC. And AB and AC are the refracting faces. So these two refracting plane faces incline to each other, making an angle A here. And this angle between the two plane refracting faces, we call it this as angle of prism. And this angle of prism is also again denoted by A, capital A. Got it? Yes, let's see how it takes place. So this is the incident ray, refracted ray, and emergent ray. So if there are two normals like this, N1 and N2 at the point of incidence and at the point of emergence, and if these two normals are meeting at the point O, then what happens? This O will be, if you take it this quadrilateral, okay, this will be one of the angle of that quadrilateral. So let's take it that this I is the angle of incidence. Angle of incidence means what? Angle between the incident ray and the normal at the point of incidence. Likewise, the angle of emergence means the angle between the emergence ray and the normal. Got it? So let's try to see the relation between all those things. But before that, I will just like to show you how dispersion takes place, okay? That will be very interesting. So let me show you that one. So this is your prism. And if a white light is allowed to incident onto this prism, then what happens? It splits up into its constituent 7 colors and it will incident onto the screen there. You must be knowing that of big here, no? Violet, indigo, blue, green, yellow, orange, red. So what happens in this white light? It consists of 7 different colors of having different characteristics, 7 wavelengths corresponding to those different colors. Okay. So those different colors have been split up when it refracts through this prism. But you will not find this dispersion in the case of glass lens. Why? Because the opposite faces are parallel to each other. Got it? Wherever it getting inside, wherever it goes away, emerges out, those two sides are parallel to each other. And because of that, what happens? You will not find that dispersion. Dispersion is taking place, no doubt. But it again, it recombines again, it comes out again as a single emergent ray. Got it? Yes. So let's go back to that of this previous slide and let's see the diagram first. Okay, how it goes like this. Let me show you again that one. So this is your glass lens. I'm showing in a very big way. Okay, so that you can all visualize it. So this is a prism ABCD having refractive index. Okay, mu. Then what happened? Incident ray, refracted ray, and emerges out as emergent ray. So these are the normals, angle of incidence, angle of emergence. This is the emergent ray, normal. So angle between them is angle of emergence. Next, there are 2 angles of refraction. We call it this first refraction as angle of the refraction R1, another angle of refraction as R2. Got it? And this is the intersecting point of the 2 normals N1 and N2 at the point of emergence and at the point of incidence, at the point of incidence and at the point of emergence respectively. Okay? So now if you take it that this is the original incident ray direction, okay, and this is the emergent ray. So this ray, after passing through this glass lens, this ray has been deviated to here. Okay, so the angle between the original incident ray and the emergent ray, we call it this angle as angle of deviation, and it is denoted by del. I told you that this del is not a Greek letter, this is not an English letter, not a stylish D. Got it? But rather this is a Greek letter known as del, and it denotes the angle of deviation. Got it? Now, after having been known this, so let's take it some points like this. Okay, P, D, Q, O. So I will do that mathematical part. Okay, let's see, like this. I'll just make it a squiggle here so that I can work it here. So if you are taking in that quadrilateral, okay, in quadrilateral A, P, O, Q. APOQ, we know that sum of the 4 angles of a quadrilateral is how much? Sum of the angles here, 360 degrees. So let me call it this as angle A, angle P, plus angle O, plus angle Q. But here this angle P is 90 degrees because this is normal. Here also normal, so angle Q is 90 degrees. So 90 degrees, how much? Angle A, you keep it as angle A, and for this angle B, it will be 90. For angle O, you keep it as angle O. For Q, it is 90 degree. So this must be equal to what? 360 degree. 90 degree means 180. So if you minus 180 from this 360, then you will get it as angle A plus angle O will be equal to 180 degree, right? So you keep this as a first equation. Got it? In the next one, let's take it this triangle OPQ. So in triangle OPQ, last lens, can you see? See now? Okay, so in triangle OPQ, we know that sum of 3 angles of the triangle is how much? 180 degrees. So then we call it angle P plus angle O plus angle before calling this as angle P, so let me call it as R1 as it is already there, okay? So instead of putting those angles, let me put as like this. R1 plus O plus R2, this will be equal to 180 degree, right? 180 degree like this. So what happened? If you name this as equation 2, and if you equate with this, okay, then you will get it that A will be equal to what? R1 plus R2. That one will come later on. Now let's see. In this exterior, here, in this triangle, PDQ, angle D is here. So exterior angle of D in what triangle? In triangle PDQ, right? In triangle PDQ, exterior angle of angle D will be equal to what? Sum of what? Interior opposite angles. So interior opposite angles are nothing but this is I. Can you see? Vertically opposite angle, right? So this will be what? I. So from I, if you remove this R1, if you subtract it, then you will get it this one of the interior angles, right? So let me tell it that instead of that like this, I, angle I minus what? R1. This will be the first interior opposite angle. The second interior opposite angle will be what? From E, if you subtract this R2, then you will get it the second interior angle, that is angle E minus angle R2. So let me do not put this angle, okay, then it will be better, I think. Got it? Like this. So this is your second interior opposite angle. So let's try to rearrange in this way. I plus E, taking minus common, then it will be R1 plus R2 like this. Got it? And let's name it this as equation 3. So from this, what? Equations 1 and 2. From equation 1 and 2, we get what? We get like this. A plus angle O, this will be equal to what? R1 plus O plus R2 like this now. So O you cancel it and you will get it angle A is equal to R1 plus R2 like this. Got it? And let's give it this as equation 4. Got it? And let's try to put this equation 4 here again, so that this will be replaced by A. So your equation 3 reduces to what? This will be your A, right? A, if you transfer it this side, then I plus E. Let me write this left hand side first, and whatever that to come on the left hand side, let me write on the right hand side. So this will be equal to A plus B. Angle, I just removed it, okay? So A plus B. Got it? So this one, D means what? Your del, this exterior angle of D. So I have to put it as this as del. So not D actually. I'm not taking angle D, rather this exterior angle of D means what? Del. Got it? So I should put del here like this. So this will be your fifth equation. Got it? Now let's see some condition. There is a specific condition that in the case of prism, okay, when if you try to draw a graph between, okay, this deviation and angle of incidence, at first what happened? Your angle of deviation is very high when angle of incidence is very small. That means when you keep on increasing the angle of incidence, angle of deviation will keep on decreasing. And at a certain point, what happens? It will be the minimum. And then if you keep on increasing the angle of incidence, then what happens? Your deviation will again increases. So the graph will be just like this. Got it? So this particular point where your deviation is least or smallest, we call it that point as minimum deviation, and it is denoted by del m. At this point, okay, when del is minimum deviation, then what happens? Your angle of incidence at this point, it will be equal to angle of emergence, and again your angle of refractions these two will be again same again, equal. And moreover, your refracted ray will be parallel to the base of the prism. Got it? So at that condition, let's see. At that condition, at what? At del is equal to del m, that is minimum deviation. What happened? Your angle of incidence will be equal to angle of emergence. And then what happened? And your R1 will be equal to R2 equal to R. Let's assume it. And let's try to put it all these things in this equation number 5. So that what happened? It will be when I plus I A plus, instead of del, you have to put it this as del M. Then this will be equal to what? Twice I will be equal to A plus del M. So your I will be equal to A plus del M divided by 2. This is 1. And in equation number 4, and equation 4 reduces to, and equation 4 reduces to what? Let's see. In this condition, R1 and R2 are equal now. So let's put it those value here, that A is equal to R1 plus R2. Instead of that, let's put it as R plus R. So that this will be equal to twice R. That means your R will be equal to A by 2. Right? So let's use it, these two above equations. I will just enclose it with box. If we use it these in our Snell's law, Snell's law में क्या था? Snell's law. Therefore, yes, refractive index, okay, refractive index of prism. So let's denote it by n like this. This will be equal to what? Sine of angle of incidence to the sine of angle of refraction. So what? Sine of angle of incidence means this is I. So A plus del M divided by 2. R means here A by 2. So sine of what? A by 2. So this is your refractive index of the material of the prism with respect to air. Got it? So by knowing this angle of prism and angle of deviation, you can easily calculate the refractive index of that material of the prism. And this is known as prism formula. Got it? This is known as prism formula. Clear? So let's try to revise it again, the whole thing. Okay? I will give you back the whole thing. Right? So let's remove it, and if you want to copy it, whenever we revise it again, we try to copy it. Okay? So let's see. Let me remove these things first, and then we will try to see it. Here. So these are what? This is the prism that we have seen, angle of deviation here. So what? These points are P, P, Q like that. So you see in that quadrilateral APOQ, sum of this A and O must be equal to 180 degree because these are 90 degree in the quadrilateral. Two of the angles are 90 degree each. Since what N1 and N2 are parallel. EQ. Got it? Sum of these angles, the three angles is 180 degree. So from there in this triangle, what are your DPQ, accelerated angle is equal to sum of the interior opposite angles. This is one of the interior opposite angles here and another will be here. Okay, just as I said. So what happened, you will get like this in equation number 3. So next is what? From equation 1 and 2, your A will be equal to R1 plus R2. Got it? And if you put it here, that, okay, equation number 3 will become what? L is equal to I plus E. Instead of this, you replace it by A. And if you what? That simplification, then I plus E will be equal to what? A plus L. Got it? Yes. So sum of the angle of incidence plus sum of this emergence, Sum of the angle of incidence and emergence will be equal to sum of the angle of prism and the deviation. Okay. Now let's see in the next one. This is the variation of angle of deviation with that of angle of incidence. So you will see the curve like that. Well, in this along angle of incidence, deviation is plotted along y-axis, then you will see the graph like this. So when angle of incidence is very small, deviation is very high. So when you keep on increasing the angle of incidence, deviation decreases, and last it will be minimum here. So that point where the deviation is minimum, we call it as minimum deviation denoted by del m. Angle of incidence is equal to angle of emergence at that condition of minimum deviation, and also your R1 is equal to R2, okay, at that condition. So now what I said, at del is equal to del m, angle of incidence is equal to angle of emergence, and your angle of refractions are also equal. So what happened, your refractive index, okay, of that prism can be done easily from here. A is equal to 2R. So R will be equal to what? A by 2. Okay, this one. Got it? And let's see for that of the angle of incidence. Our main purpose is to find out the angle of incidence and angle of refraction in terms of some known quantity, like that of angle of prism and minimum deviation. Got it? So from here is equation number, what number? 4. I think 4 now. So what happened? I plus E is equal to A plus del. So at this condition, what happened? You need to put this as I here instead of E. Instead of del, you need to put as del m, and then what it comes, let's see. Like this, I will be equal to A plus del m divided by 2. So according to Snell's law, what happened? If you try to put it there, sine I and sine R, I and R, replace it here by this expression. I is equal to A plus del m by 2. R is equal to A by 2, then you will get the refractive index. Got it? So this is what we call as prism formula. When one asks you what is meant by prism formula or what is prism formula, then you need to say that prism formula is a formula, okay, or an equation relating between refractive index of the material of prism and what? The angle of prism with that of minimum deviation. So a relation between refractive index, angle of prism, and minimum deviation, we call it that relation as what? Prism formula. Okay? So let's try to do one small question. Okay? You can do it this as your home assignment. It's very easy. So calculate the refractive index of an equilateral prism. Equilateral prism means all the angles, okay, between any two edges will be what? 60 degree equal. Okay? And for which a ray of light incident on it shows a minimum deviation of 30 degree. That means angle of prism is also known. I'm giving you hints here. Angle of prism is how much? 60 degree. Minimum deviation is how much? 30 degree. So if you try to replace this value in that what? Prism formula, you will easily get it. Got it? You can do this one right now also. So we can start that mu is equal to what? Sine of what? A. A means 60 degree. 60 degree plus del m means 30 degree divided by 2. Sine of what? A by 2. A is 60. So 60 divided by 2. Let me write everything here, okay? So let's do it this one. So sine of how much? 60 plus 30 means 90. 90 divided by 2 means 45. And here this is sine of 30 degree. Sine of 45 means how much?
1 under
1 by?
under
1 by? Root 2. 1 by root 2. Okay? And sine of 30 degree means 1 by 2. Like this. So it will be what? 2 divided by root 2. That means it will be root 2. So root 2, the value of root 2 is 1.414. Got it? So your refractive index is getting like this, 1.414 like this. Huh? That is a refractive index. So next, I will give you another, this will be our last one, and I will give you another homework, okay? This is very easy, so I will wrap it up. If you want to copy it, let's do it later on. You can do by yourself. This is for your homework. Okay, copy it.